Hi, in this video I'll try to cover a very peculiar problem that many organizations face, where they have got multiple tools and systems, and they have got a stack of web services which are interacting with each another, and the whole ecosystem looks like a nervous system where you have kind of a JSON's payloads floating from one web service to another web service, and it's quite kind of looks from the top, it looks like quite massive job to manage all this whole system, yeah, solution. So the main challenge, if you see, is to manage to basically validate the payload that floats across this whole system from one web service to another web service. So there's always a tussle that, okay, the validation should be done at the origin or should be done at the destination. To reduce that kind of a fight, I just thought of putting up a centralized JSON validation mechanism. Basically payload validation mechanism, and expose that as a web service to, so that these micro web services can further call this is validation program, pass their payload to get it validated from this web service before they can further process it. Yeah. So this whole project is organized like this. So I've got a main program which actually exposes three functions which are defined in this module over web service. Now the crux of this is based on a Python module which is called JSON schema. Yeah. So I'm using this module to kind of do the validations, and I've written three functions actually. One to list the web services, list the JSON schemas which I'm going to validate, view the schema definitions, and then obviously at last just check the schema. Yeah. So checking the schema. So with that, I'll just launch the program. Basically the web service schema service config is equal to config.json. So all the schemas which are defined in schemas directory, for example, before that I'll just show you how it's set up. So in the schemas directory, I do have individual schema definitions. So for example, user schema is defined here. This is just an example. You can just write your own schema files. Yeah. So here I've got ID, name, login, password, and out of these four I just require two. If ID and name are not present, that is fine. We'll just ignore that error. Yeah. And however, if ID is present, then ID must be of integer type, and it should be between 2 and 10, right, including 2 and 10. Similar validations are applied on other fields also. And with that, I'll and all these schemas are further being enabled via config.json. So in the main config.json, I'm just pointing, say, user schema is defined at this path, address schema is defined at this path, now test schema is defined at this path. Now this is not existing, so I just added it up to simulate a negative scenario. So with that, I'll okay, service is already started. So I'll just show you that how the list function looks like. If you want to see more details on the validations, syntax, and semantics, you can visit jsonschema.org. Here you'll get quite extensive knowledge of syntax and semantics, validations, and types, and all that stuff. Yeah. So I'll just first list the schemas. So I've got, say, three schemas. These are coming out of the config.json: user, address, and test. Now that we know that there are three schemas, so I'll just try to view them. So I just see the user definition. So that's how my user JSON looks like. This is exactly the same which is being defined at the backend. Yeah, it's just that, okay, you can still see the definition over web service, yeah, rather than going to the backend. Now we'll try to consume this web service in Postman. We just try to validate it via Postman. So for that, the function name is schema check. Yeah. So this function, if you remember this schema definition, basically going back to the browser just a second, it says that ID should be between 2 and 10, including 2 and 10. However, in Postman I've mentioned it as -1, so here it should return us an error, and it does. So it says error code -1, invalid data. -1 is kind of less than the minimum value. So now we'll try to put this between 2 and 10, say 4. Now it says it's okay, and the error code is 0. Now we'll do some more changes to this schema file. Maybe I'll try to make it enum, yeah, just to simulate it. So I'll say this is of type integer, but I want to keep the values coming out of enum. So I just say enum, and in here I just define a list of say 1, 3, 5, maybe 7. That's it. So sorry, just wait, 57. Just put it, yeah. So now if value is out of one of these, then only it will return okay. Otherwise, it will throw in an error. So now just say for example 9, and just pass this thing. So it says invalid data, and reason is 9 is not one of these enums enum list, yeah. And moment I say it's say 3, it will say the data is okay, yeah, and it will pass this thing. Now another thing which if the schema is defined as the required attributes. Required is login and password. If I remove ID and name, that should still pass. So I'll remove ID and name out of this, and it just passes this thing. It says error code 0, and message is okay. Now if there is a corruption by any chance to the schema file, for example if you just forgot to put some comma or anything like that, so I'll just remove this comma for example, and if you give a call to this function, to this API, you'll get schema definition is corrupted, is not found, or corrupted. So you can go back to the system and check, okay, where is the problem, yeah. I'll correct it one again. And another scenario is covered, which is basically if you have defined the schema in your config.json, but it is not existing on the system, for example this thing. So if you try to view this schema, it will throw you an error. So for example if I view test, it just says okay, schema definition not found, yeah. So if you see the usability of this project is basically you can maintain multiple schema versions in your Git repository, and it can become actually part of your change management itself. So along with the code, you can maintain the JSON schemas within your kind of change management process, and that actually kind of eases down the job of overall job of maintainability of the code and project, yeah. And plus, I mean, it actually cuts down your development time, validation that you spend on implementing validation at each web service level, and obviously it just settles down the tussle between two developers maintaining two individual web services. I mean, there's no fight that okay, you validate it at the origin or I'll validate it at the destination, yeah. So they just can fire a simple web call to this web service, JSON validation web service, and get their payload validated right from there. So that's pretty much I wanted to show here. I hope you do find it useful, yeah. Thanks for watching.